Hello, everyone, and welcome back to day 3 of 100 Days of Code Challenge. Today's we'll be focusing on control flow and logical operators. In front of me, I have the first exercise of the day, 3.1. The instructions are here. Write a program that works out whether if a given number is an odd or even number. Even numbers can be divided by 2 with no remainder. For example, if 86 is even because 86 divided by 2 gives us 43. 43 does not have any decimal places, therefore the division is clean. 59 is odd because 59 divided by 2 equals 29.5, and so forth. Okay, use the modulo as a percentage sign, gives you remainder after division. Okay, example input, this is an odd number. Example input, this is an even number. All even numbers divided by 2 with the remainder. Try something using so odd numbers. Okay, perfect. Let's start. Let me just run this as usual. Input 99. Yeah. Number equals int equal input blah blah blah. Okay, so I will say so my thought process for this would be an if statement that checks with a modulo function input. If number modulo 2 equals 0, okay, print this is an even number. Perfect. Now, okay. Otherwise, print this is an odd number. Okay. Else, print this is an odd. Okay, I'm just trying to print this. Print. Okay, no, I don't need to put print there. I've got print there. Okay, let me run that. And let me check. 20. That should be an even number. Perfect. Okay. Let me try 19. That should be an odd number. Voila. Perfect. Okay. That was simple and straightforward. Okay, so that marks the end of exercise 1, so exercise 3.1. Let's move on to 3.2. Welcome back to exercise 3.2. This is the upgraded version of the BMI calculator that we worked on in the past. So the instructions again, write a program that interprets the body mass index, BMI, based on the user's weight and height. So now we're giving them an input as in addition to their BMI value. We should tell them the interpretation of the BMI based on the BMI value. Over 18.5, they're under 18.5, they're underweight. Over, below, and below 25, they have normal, and so forth. The BMI is calculated by the person's weight squares. Warning: you should round the result to the nearest whole number. Message needs to include the words in bold from the interpretation, etc. Okay, so an example input 85 for the weight and 1.75 in meters for the height gives you 27.75. Your BMI is 28, so round it up. And when you hit run, this should happen. Try to use the exponent of every code. Remember to run yourself to the three nearest whole number. Make sure to include the words in bold. Okay, perfect. Let's get started. So, just run it. Make sure there's no errors. 1.5. Okay, that's fine. Height and weight. Okay, Let's first calculate the BMI. BMI equals weight divided by height squared. Weight divided by height squared. Print. Let me just print out the BMI. Okay, that works fine. Delete that. So now it's just going to be a bunch of if statements. Let me just copy the instructions. Okay, commented that out. Okay, if BMI is less than 18.5, print you are underweight. Okay. And it's going to be an else if BMI is greater than 18. BMI less than 25 and BMI greater than 18.5. Print. Oh, I need to colon. Print. You. Oh, my keyboard is. You have a normal weight. How to record that? Okay. Okay, so those two are done. The third one, BMI is greater than 25, but below 30. They are slightly overweight. Okay. LF BMI greater than 25 and not below, and BMI less than 30. Print. You are slightly overweight. Finally, okay, not fine, second last. Over 30 but below 35. The obvious. LF BMI below 30. Well, below 30 and BMI greater than 30. No, great. Oh, below 35 and greater than 30. Print. You are obese. Okay. Done. Above 35, clinically obese. So I could just either do greater than 35 or anything else would be clinically obese. Because I captured below 18.5 there. So I'll just say else. Print. You are clinically obese. Let's run this. Okay. 1.75 85. Yeah, slightly. Oh, okay. I need to. Uh, didn't know the BMI number. Let me add that. Um, F uh, F string, and then your BMI. Just copy all of this. Your BMI is no. Your BMI is copy. Um, trying just to copy this part. Okay. Okay. Why is it giving me two? Okay. Underweight, normal weight, overweight. You are obese. You are clinically obese. Clinically obese. Okay, let me rerun that. Enter your height in meters. So let's say same values again. Okay, I need to round this up. How do I do round again? Round in Python. Round number and then the digits. Okay, rounding it. What's the instructions again? Round to the whole. Okay. Oh, okay. So if I don't specify decimals, so just give me um, please tell me there's no errors. I'm suspecting an error from this. Delete that. Delete that. See. Let me think on this. backward around the please work. Oh yes. Okay. 1.75, 85. Perfect. Works. Okay, great. Let me just try get the clinical obese one. So I'm gonna add 200 kg, 1.75, and you weigh 250 kg. BMI is 82, and your clinical obese. Perfect. It works. Great. So that marks the end of exercise 3.2. Let's move on to the next. Okay, welcome back to exercise 3.3. So this challenge, according to the instructor, should be quite difficult. But let's see how we get on. Okay, so I need to write a program that works out whether if a given year is a leap year. A normal year has 365 days. Leap years have 366 with an extra day in February. The reason why we have leap years is really fascinating. This video does it more justice. Yeah, let's see what the video is about.
If you work in a team, you should be using Monday.com. It's a platform to manage any team and any.
A calendar year is made of 365 days, a number that refuses to be divided nicely, which is why we.
Okay, so this is the video if you guys want to watch the video about this channel. Okay, so with this challenge, so this is the methodology for leap year. On every year that is even indivisible by 4, except every year that is even indivisible by 100, unless the year is also even divisible by 400. Okay, sounds a bit confusing at first, but let's see the example. So the year 2000 divisible by 4 equals leap. Even divisible by 4 equals leap. And if it's even divisible by 100, unless the year is also even divisible by 400, leap. So the year 2000 is a leap year based on that. 2100 is not a leap because if divided by 4 divided by 100 and 4. Okay, I think I get the gist of it, but let's check it out. Let me just copy the methodology again. No, I copied the example actually. Comment this out. Perfect. Okay. Input. I would like to run a first because there are no errors. 2100. Okay, nothing's gonna happen as expected. So the first step is on every year that's even divisible by 4. So even divisible. If year modulo 2 equals 0, that means it's even divisible. Print yeah, leap year. Okay. No, divisible by 4, sorry. Okay. Continuing, so under the same indent. Elif. Every year that is even divisible by 100. So if year 100 equals 0, What's going on here? Hmm. Okay, I think it should be an nested if year 100 equal 0, print not leap. How was it? Let me check. Right. The year also print. Let's try it out. Leap year. No, wait. Less. Yes, supposed to do it. Okay, this is tricky. Okay, let me just write the else alif for the first one. Okay, so let me start over again. If year divided by 4 is 0, if year modulo 100 equals 0, if year modulo 400 equals 0. Okay, so that's that. If okay, so if all those conditions are true, then it's a leap year. Okay, print leap year. Okay, so if the year is even divisible by 4, and then even divisible by 100, and then even divisible by 400, then it's a leap year. Else if, okay, let me write the else statements. Else for the first one, indentation, 400, not leap. Else print not leap year. Okay, that seems right. So that's the indentation for that one, and then for this if statement, if the year is even divisible by 100, 100, I read this even. Okay. So what did it say? Not leap. Not leap. Okay, so 100. Otherwise, it would be not leap. Else print not leap Yeah. Wait, that can't be not leap twice in a row. Leap year, not leap year. If divisible by 400, it's a leap year. If not, it's a leap year. If it's even divisible by 100, it's a leap year. Otherwise, it might be a leap year. Okay, okay. And if the first one, that has, if the year is even divisible by 4, then it's a leap year. If not, else not, then it, okay, print not leap year. Let me check the ones. The 2000 should give me leap year. 2400 leap year. 1989 not leap. So 2400 leap year. 1989 expected not leap year. Okay, I've done it. Okay, wonderful. Perfect. Okay, so that concludes exercise 3.3. Yeah, moving on to the next. Okay, welcome back to exercise 3.4. In this exercise, we will be building an automated pizza ordering program based on a user's order. We will be working out the final bill. So these are the instructions. So we have the prices for different sizes of pizza, the toppings, and then the example input for the user will be size equals L, add pepperoni yes, extra cheese no, and then we would sort of accumulate the total bill based on all of this. And then when you hit run, this should be the example. What do you want to order? Extra cheese yes and no. Final bill is this. Okay. Seems straightforward, but let's see if it's straightforward to code it as well. Okay, first thing first. What's it doing? Print. Welcome to Python pizza deliveries. And I think input. Add pepperoni, extra cheese. What size do you want? So let's just say L. Yes. Yes. Okay. All right. Perfect. So let me just copy the prices. Okay. So those are the prices. Comment that out. Perfect. Okay. What size do you want? Okay. So size. Duplicated it. What the hell? How? Okay. Initially, we don't know what. So since we are accumulating, let's start out with 0. Bill equals 0. Okay. And then if size, okay, that means if size equals S, a double equation, print, no, not print, I just want the price, so bill plus equals 15. Otherwise, if size equals m, bill plus equals 20, and if size equals L, the bill is going to be bill plus equals 25. Yep. So that is the pizza done. Next, pepperoni. Well, actually, there won't be any other inputs. Okay, so we've done this one. I think I need to move on to the pepperoni part. If add underscore pepperoni equals y YMCA. Okay, sorry. How much pepperoni again? And if pepperoni, if size also equals L, bill plus equals. No, okay, let me start with the small. S bill plus equals that. And if LF size equals, do you need an LF or do you need a, there's only one other option, which is 3. Else, bill plus equals 3. Extra cheese for any pizza. If extra underscore cheese equals yes, bill plus equals 1. So we're accumulating it. And then finally, your underscore final bill equals bill print your underscore final underscore bill. Let me try that. Give me large. My bad, I think it's capitals. L. Yes. Yes. Seems right. 29. Let me give it a your text. Your final bill is F string. $, LLY. Wait, L, yes, yes. Ah, oh, perfect. You finally just turned that. Straightforward. That worked. Great. So that concludes exercise 3.4. Hello, everyone. Welcome back to the final project of the day. It is a treasure island game. I already built it out, but I didn't record it, unfortunately. So, but I thought I'll still demonstrate the encode and just demonstrate the game and how it actually works. So essentially what we have here is a choose your own adventure game where the story evolves based on a set of inputs and choices that you create in an if statement. And this is all based on everything we've learned so far. But let me show you the game in action and then yeah, we can take from there. And by the way, this I didn't actually draw it out. You can find it on Google. That's a website that actually gives you this kind of information. But yeah, let me run it and then I'll demonstrate the game in action. First question, your mission. Okay, so your mission is to find the treasure. You're at a crossroad. Where do you want to go? Type left or right. Let me type right. You fell into a hole. Game over. Boom. Restart the game. Okay. Let me type left this time. You've come to a lake. There is an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. I'll wait. You arrive at the island unharmed. There is a house with 3 doors, one red, one yellow, and one blue. Which color do you choose? Like a matrix, right? The red pill, blue pill. Go for the blue. You enter a room of peace. Game is over. So essentially, yeah, that's how the game works, and it's based on this code here, which essentially first greets you, and then greets you with the mission statement. Choice one is a simple input. Type left, right, right, and then if choice one equals left, you know, and then the else condition is here for that one. You fill into whole game over. If not, continue, and choice equals wait. Then yeah, you arrive unharmed and game carries on. So it's simply just if statements and inputs, if else conditions. So yeah, that is the final project of the day. And yeah, I'll also be uploading this to my GitHub page. But yeah, thank you for watching, and I'll see you tomorrow for day 4, inshallah.